Welcome back to this series of videos on data engineering using Azure. So in the last session, we saw that how we could run an AutoML job. And even though we did not proceed to the last step where it automatically finds out the best model from the library of models Azure has, but we stopped cancel the job in between because otherwise we have taken a very long period of time. But we did find out that within that period of time, it has selected many models and it was gradually improving the performance of the model. We also saw that he said that once we have selected the model, we need to have an interpretability of the model. That means we need to figure out that which features have affected the decision of classifying a particular observation into diabetic or non-diabetic, because explainable models are one of the important criteria today. Users are expected to, or sometimes even required to ask that what are the factors that has caused the model to classify an observation into one class versus the other class. Okay, this is called explainable AI. And here, if you see that it will give you, once you have selected the model, it will automatically give you the explanation of the model. So if you go to view explanation, let's see what happens. Okay, so here you can see that it is giving us various types of data. So the first data by default, what is giving, and it is a very important data, which is what are the features of the model that are most important in determining whether a particular class is 0 or 1. Okay. Now here you can see that the class is so the importance of the features may not be symmetric. That means the feature that is important to determine if a particular observation belongs to class 1 may not necessarily be important to determine if the particular observation belongs to class 0. So what we are interested here, we are interested not in class 1, class 0, because class 0 is a non-diabetic class. We are interested in class 1. And we want to know what are the features that are impacting a decision that whether a particular observation has belonged to class 1 or belong to class 1. So we see the most important factor here is glucose. So which means that glucose, the value of glucose decides whether a person is diabetic. We also saw that the value of glucose also determines whether the person is non-diabetic, which may not always be the case. It's not symmetry. Glucose might be determining whether the person is diabetic, but may not be determining whether the person is non-diabetic. But in this case, that's not the situation. And the next important factor is age. The third most important factor is BMI, body mass index, and then something called diabetes pedigree function. We don't know exactly what that is. That's a medical term. But these are the four most important features that determine whether an observation will fall in the class of diabetic or non-diabetic. Now I can decide whether I want more than 4. Increase this, I'll get more than 4 features. Okay. If I reduce this, I can get less than 4 features. Okay. Also, I may want to have a box plot. Just let's see how the box plot looks like. Now the box plot is very interesting. Now the box plot basically says that uh, what is the importance of the feature on the positive side and on the negative side? Remember, what is the positive side? The positive side is the person observation is diabetic. So we saw that this particular feature is actually having a very important role both when the observation is diabetic as well as when the observation is non-diabetic. But if you look at the box plot, you see that if if the the role of glucose in determining a person is non-diabetic is higher than the role of glucose determining the person is diabetic, because the median value is below 0. That means in more number of cases, we have a situation where if the person is, if the glucose value is less, it is correctly predicting that the person is non-diabetic, compared to when the glucose value is more when predicting it's diabetic. So the importance of glucose in predicting whether a person is non-diabetic is more than the importance of glucose when predicting when a person is diabetic. On the other hand, if you look at the age, it is the other way around. In case of age, the importance of age in predicting a person is diabetic is more than the importance of age when predicting the person is non-diabetic. And so is BMI, whereas the diabetes predictive function is the other way around. However, if you look at the variance of the viscous, you see that there is a bigger variance in terms of the glucose. That means there are some cases where the importance of glucose in determining a person of diabetic is very high, extremely high. So for that particular instance, it's extremely high. Though overall, the importance of glucose in determining the person is diabetic is less than the importance of glucose in determining a person is non-diabetic. But there are a few cases where the importance of glucose in determining the person is diabetic is very, very high, abnormally high. Okay, so that is what this particular data is saying. Okay. So you can also take some dependence plot. For example, I can select a feature, let's say glucose. And I can see the dependence plot. Yeah. So when the glucose is, and this is of course from our common sense as well, we understand this, that if the glucose is towards more than 100, so around 120, 110, then the importance of glucose in determining diabetic or non-diabetic is neutral. If the glucose is much below 100, then definitely the importance of determining whether a person is diabetic, importance of glucose determining a person is diabetic is very high. Otherwise, what it means, if the person is having a glucose less than 100, then unless there are some other feature which is very, very abnormal, which is pulling the person to a diabetic side, there is a high chance the person is non-diabetic. On the other hand, the importance of glucose to determine whether the person is diabetic when the glucose level is probably more than 120 or so is very high. But you see that is not as high as the situation where the glucose is low. The importance of glucose in determining the person is non-diabetic. That role of glucose, the glucose is low, the role of glucose in determining a person is non-diabetic is far higher than the importance of glucose in determining a person is diabetic when the glucose is higher. Let's go to some other data. If you go to the model performance, we can take this cohort and we can probably take the predicted Y class. We can see that how many cases have been predicted as diabetic and how many cases have been predicted as non-diabetic. And now we can look at the various parameters. For example, we can look at, again, glucose. We are taking glucose because that's a more common thing and we can easily analyze that data. We can see here very easily that when the glucose level is 40 to 79, almost every case is non-diabetic. When the glucose is between 80 to 119, majority of the cases are non-diabetic. There are few cases which are diabetic, but moment it crosses 120, the number of diabetic cases significantly increases, and when it causes 160, definitely a person becomes diabetic. So again, this corroborates to the fact that the importance of glucose in determining. Also, it talks about the distribution of the diabetic and non-diabetic cases across the different glucose values. Now, if I change these to, let's say, uh, something else, let's say blood pressure, let's see what happens. Okay. So again, if you see, very interesting, blood pressure situation is not that same. When the blood pressure is 25 to 48, uh, I don't think the blood pressure, somebody has a blood pressure after 48, but then probably those can be some erroneous things. Okay, so when this is the blood pressure, you see that but a blood pressure which is much below, you see, is completely uh, diabetic, and probably a very low blood pressure also indicates that the person is diabetic, okay, or is likely to make a person diabetic. On the other hand, as the blood pressure grows between 49 to 73, you see that there are people who are diabetic and non-diabetic, 49, 74 to 97. Like, so now one thing is very clear that with blood pressure, I cannot find a very strong correlation, unlike glucose, unlike blood sugar. So that was very clear. Above 120, moment goes above 120, there's a large portion of them are diabetic. But in blood pressure, you see that it is almost equally split. And we also saw that when we figured out that which particular metrics are affecting or influencing glucose, we are influencing diabetes. And we saw that blood pressure is not one of the major ones, or not one of the most top four at least. Okay, so this is clear also from this thing that blood pressure is not a very strong determining factor in determining whether a person is diabetic or non-diabetic. Okay, so this, so like that we can do other analysis as well. Now this is where we can do some box plots. This the visualization is still, I think, little, the interface is still to be fully developed, so that's why you see all this overlaps. So let's say instead of index, we make this as predicted y, or let's say even true y. And you see that if I take again glucose, you can see here that when an individual is non-diabetic, obviously the glucose level is much lower, but there are outliers. That means there are people who are having a very high glucose level, but yet they are non-diabetic, and their very low glucose level also are non-diabetic. On the other hand, if the glucose level is high, then it's almost certain the person is going to be diabetic. But if the glucose level is low, then there can be outliers. Okay, there can be, rather the other way around. If a person is non-diabetic, there can be a non-diabetic person with a high uh, blood sugar level, okay, a high glucose level. But a person with a high glucose level is almost invariably going to be diabetic. Okay, so that's what it's saying, and I can do that for other features as well. For example, I can look at age. And we can see here that when the age is less, most people are non-diabetic, but there are people with where the age is high and still they are non-diabetic. On the other hand, as age increases, the possibility of diabetes is higher. Okay. So we can do that. Uh, this we have already seen, aggregate feature importance. And there is something individual feature importance. Individual feature importance is basically uh, for any specific individual data set, okay, so, individual data. So I can just say true Y and make this glucose. I'm showing glucose because it's much easier. Now I can take each, so these are individual data points. Okay. So these are the data points where the observation is diabetic, and most of them the glucose level is high, and here the observations are non-diabetic, and most of them glucose level is low. Now, when we talked about the importance of each of these features, we saw overall importance. But suppose I want to take this particular data and I want to know that what is the importance of the features for this data. Now we have two data sets actually. One is row 0 and row 501. And we want to find out what is the importance of each of these features on this. Okay, so now we see that and both are class 1. So here you see that age is having an importance on the negative side, that is, it's having an importance in terms of determining the class is not 1, whereas BMI and glucose, BMI is determining that the class is towards 1. And similar, but you see a difference between the two observations here between row. So I can just take row 501 probably. Yeah, the comparison row 1 and row 501. I can just take one row actually, the row 501 is here. So what is saying that the class is diabetic, we know. Age, for this particular observation, age is actually, age data is pulling the observation towards the non-diabetic side. The data about age is saying that this person is likely to be non-diabetic. Whereas data about BMI is saying that the person is likely to be diabetic. Data about glucose is saying that this person is likely to be non-diabetic. And, and diabetes predictive function is saying the person is likely to be non-diabetic. So overall, it is saying the person is likely to be diabetic, but that means the BMI has a very, very strong influence in determining that for this observation, the person is diabetic. So most important factor for which this person has been considered to be diabetic is BMI. So this person says that, why is it that you are diagnosing me as diabetic? You always say that you are being diagnosed as diabetic because your BMI is indicating that you are diabetic. That is the most important reason. So that is called an explainable AI. This is an example explain. You are able to explain what is the reason for which you have classified a particular observation to be in a particular class. Okay. So I hope that we have seen through these last 3-4 videos how AutoML can really be a huge benefit to data scientists.